Hello, good day to you all, my wonderful children. How are you all doing? How are your parents? And how are you coping? I know you're missing your friends in class and you're missing me, your teacher as well. Okay, I miss you too as much as you miss me. But what can we do at this period of coronavirus spread, especially at this stage where it is the community spread? And we have to observe all the safety precautions. Number one, which is social distancing. We should not gather in a place. We should not be more than 20, gathering together in a place. So that is why we have resulted into this online teaching. And I hope you have been enjoying all the classes we have been dishing out to you guys. And I hope you're taking advantage of these to get yourself prepared for all your external examination. Please do go online to access the lesson notes as well as the video. You have done first test, which is going to be recorded in your continuous assessment, and you're going to be writing the second test soonest. I will tell you in the next class when the second test shall be written. Please update yourself on all the videos and the lesson notes online. Yes, I remain your teacher, Mr. Ogunlaro, and yet you are welcome to yet another class. Today we shall be treating a subject called Basic Science and Technology. What did I say? Today we're looking at the subject called Basic Science and Technology. And the title before us today is Force. What do you think force is? Force. What comes to your mind when you hear the word force? Push, pull, drag. Anything, every word that relates to force are those words that I've mentioned. Push, pull. What does it mean to push something? What does it mean to pull something? All these and more we shall be looking at today. But before we proceed, it is very necessary that I tell you this topic is for the 8th week. And like I told you, the subject is a basic science and technology. And the topic again is force. And this is for primary 6. Before I go on, it is very necessary I take you through the learning process or the learning objectives that those things you're expected to know or to have learned at the end of this lesson. So the next slide, I'm going to be telling you those things that are expected of you to have learned at the end of this lesson. First, at the end of this lesson, each of you should be able to define force. You should be able to explain what force is. The second of all, you should be able to list and explain the types of force. You should be able to list and explain the types of force. And thirdly, you should be able to state the effect of force on an object. You should be able to state what force does to an object. And lastly, you should be able to mention examples of force. All right, let's take a ride as we go into details in the topic of today. All right, the first thing I'll be telling you is the definition of force. Like I explained, or I asked in the beginning of this class, what do you think force is? Okay, I give you an instance. Have you ever pushed a person or a thing or your classmates or even your siblings? Have you ever pushed any one of them? Okay, keep the answer to yourself. I will ask you again by the time I'll be explaining in details the meaning of force. Have you ever pulled something? What does it mean to pull something? Have you ever pulled any of your siblings or your classmates or a thing? Okay, yes, let's quickly go into the meaning of force. What is force? Now, force is a push or a pull on an object which caused the object to either move from where it was before to a new place or stop the object from moving. I take that again. I said force is that which makes an object to move from where it was before to a new place or cause the object to stop moving. I give you an example. You like football, right? Yes, football is not for only male. Females still play football. We have female soccer, right? And we have female football team around the world, okay? Now, if you kick, okay, before you kick the ball, let's assume the ball was first stationed at a place. What that means is the ball was at a place, not moving. Until you, yes, you looking at me, until you go there and kick the ball. Now, when you kick the ball, what you have done is you have exerted a force on that ball, which will cause the ball to move from where it was to a new place in the direction you have kicked it. If you kicked it in an upward direction, it goes in that direction. If you kick it in a sideways direction, either to the left or to the right, it goes in the direction at which you have kicked the ball. That is force. And we apply force to virtually everything we do in life. Take, for instance, your house chores. Do you know you need some sort of force to get the chores done? You want to wash the dishes in the kitchen. You need force. You need to exert force on the sponge that you use to scrub the dish to get it clean. You want to wipe the dirty surface of your table. You need a rag or a napkin, and you exert force with your sanitizers, of course, to clean the surface of that table. Likewise, if you want to mop the floor, you need some sort of force or energy to apply on the tiles of your house to make sure the dirt are wiped clean. So force is very, very necessary. An application of force is visible in every aspect of our lives on a daily basis. So let's go to definition of force. All that I just said came out from my head and I just explained. So let's go to what I just put down here. I said force is a pull or push of an object which causes the object to move from a position or stop the object from moving. I said that earlier. If you apply force to a thing, you apply force to an object, obviously the object is going to be shifted from where it was before to a new place because you applied force. And the movement, how far that object will go, will be determined by the quantity of force that you apply. If you apply force to a thing, that thing can travel based on can travel a distance based on the quantity of force that you have applied. I hope that is clear. So come with me as we go further into this topic. I said force is the product of mass of the object and its acceleration. All right, you just need to know this. There are some questions that comes from different exams that you'll be writing. Some of you that will be writing Navy Common Entrance, some of you that will be writing Federal Common Entrance, and all sorts. Now, you never can tell. You can be told or you can be asked what is force mathematically. So force is the product of mass times acceleration. Someone wants to ask me what product is. Have you forgotten mathematics? I taught you all. Product means multiplication. When you multiply two things together, the result is the product of what you have multiplied. For instance, the product of 2 and 3 is 6. So the product of 2 and 3 is 6. What I have simply said is the multiplication of 2 and 3 is 6. The answer is, so that's what product means. So force is the product of mass. Mass is the weight of that object that you want to push or that you want to pull. And its acceleration. Acceleration is movement of the object in a particular direction. Are you getting it now? So when you push a thing or when you pull a thing, you are doing so you're applying force in doing so, and you're doing so in a particular direction. And that object is going to go in the direction of the force that you have applied. I hope that is clear. I hope that is clear. All right. Now, I've said here that the greater the mass of the object, the greater the force required to move it. Yes. If you want to push a car, for instance, some of you are lazy bones. In order for you alone cannot push a car because the car is so heavy. It will take a lot of people to gather around to push the car. Is that okay? Now, that was what I just said here. The greater the object, the greater the force that is required to push that object. Like I said, you want to push a car, the car is so heavy, it requires the equal force. It requires the equal weight of that car to be pushed. I repeat what I just said. For you to push a car, you require the equal weight of that car. The same force is required to push the car. Therefore, one person cannot push a car. You need to get people that will equal the weight of the car to get the car pushed. Okay, let me paint a scenario here, or paint a scene. Let's assume you are traveling on a picnic with your siblings, your family members, and you were in a car. And suddenly, maybe, in the middle of the road, your car broke down. There is no mechanic in sight. No one to come to your rescue. What do? And you ask around and someone said, oh, the next mechanic village is about 30 minutes drive from where you are. What do you need to do? You'll just look at yourself and call yourself by name and say, Daddy, Mommy, we have to push. So you need to start pushing the car from where it broke down to the nearby mechanic village. What you have done is simply apply force. Use combined force to get the car. So I said, in order for you to get that car pushed from where it broke down to a new place, you require combined force. That means you and your entire siblings need to come together to get the car pushed from where it broke down to the nearby mechanic village. So that is force, application of force at work. You have applied the combined force of you and your entire family members to push the car from where it broke down to a new place. So I also said here that a force is a vector quantity. A force is a vector quantity. Why is a force a vector quantity? A force is a vector quantity because it has both magnitude and direction. That might be ambiguous. That word might be big for you. Let me break it down. What it means for an object or a force to have magnitude is it has weights. W-E-I-G-H-T. That force has weight and it also has direction. I said in my explanation that in order to get something moving from where it was before, you need to apply what? Force. And if you apply force, that object would go from where it was in a particular direction of force that you have applied. If you have kicked a ball in an upward direction, the ball is going to go in that direction. If you kick it in a sideways direction, either to the left or to the right, the ball is going to go in that direction. Now, for you to get an object moving from where it was before, you need to apply an equal force of the weight of the object. For instance, if a ball is 20 kilograms, you need to apply an equal force of 20 kilograms to get the ball moving. I hope that is clear. You want to lift a box. The box is 50 kilograms. You need to apply equal force of 50 kilograms to be able to lift the box. I hope that is clearer now. You need to push a car. The car weighs about 350 tons. You need to gather people that will apply equal force of 350 tons to get the car pushed. It's simple. So a force is a vector quantity because it has magnitude, that is weight or mass, and direction. And examples of force are pull, push, tension forces, and frictional forces between two surfaces. We're going to take frictional force as a topic. So now let me quickly explain something to you. Pull and push. I said a force is a pull and push effect acting on an object which causes the object to move from its position or stop moving. Okay? So that makes a force a vector quantity because it has a magnitude and direction. And force is measured in Newton. Now, what is a pull? A pull is the force that brings something or an object closer. If you pull an object, that means you are bringing the object closer to yourself. That's a pull. And if you push an object, is a force that takes an object away from you. So if you push an object or you push a thing, you are taking that object away from you. You must have gone to malls or pharmacy where you're about to enter into the pharmacy or a mall. When you see push, it's boldly written on the entrance of the door or the glass or whatever, that for you to enter, push the glass. And when you push, what happens? The door opens and you go in. Now, if you are now going out, there is another sign that reads pull for you to go out. In order to get the door open, now you are going out. In order to get the door open, you need to pull. So to open the door before going out, you need to pull. So when you pull, the door opens and you go out. So those are the application of force. Now let's go to types of force in details. We have two types of force. I have just explained application of force. Now I've explained that one of the application of force is getting a car pushed from where it broke down to a nearby mechanic village. And that is the same thing I've explained here. You must have seen a broken down vehicle in your town or village. Assuming this car is to be taken to a nearby mechanic village, what do you think you must be done to it? You know, take the broken down car to the mechanic village. To take the broken down car to the mechanic village, you have to push it or get a towing van or towing vehicle. Now, a towing van or a towing vehicle is these big trucks that have the ability to be able to pull a broken down vehicle to where it will be repaired. You must have seen it on the way. These last mile guys, they have big towing vehicles that get trucks and lorry that breaks down on the road, off the road. So the pushing or pulling of the car to the place where it will be repaired is an application of force. I said that earlier. It is force that is pushing or pulling the car. To make the car go faster, we push harder. That is, we apply greater force. I also explained that earlier. Note that pull and push are examples of force. Okay, now let's go to types of force. Types of force. We have two types of force, and they are contact and non-contact force. There are two types of force. We have contact and non-contact force. What does it mean for force to be contact? Or what do we mean by contact force? Now, let me quickly explain. Contact force is the force that exists between two objects in contact. I explain further. In order for you to get a particular object moving, you need to come in physical contact with that object. For you to push a car, you need to go close to the car and make sure your hands are touching it to be able to push it. That is contact force. In order for you to kick a ball, you need to go close to the ball and your leg touching the ball to kick it. That is also contact force. There's another one called frictional force. Now, is the force that exists between two objects in contact. Frictional force or force of friction is the force that opposes motion between two surfaces in contact. Now, let's go to contact and non-contact force in details. The first one here. Two types of forces. Number one, we have contact force. A force that acts at a point of contact between two objects must be touching. I just said that. So it's a force that acts at the point of contact between two objects. The two objects must be touching. You want to kick a ball, you have to move close to the ball to kick it. You want to push a car, your hands must be touching the car to push it. You want to lift a box, you have to bend down, making sure that your hands touch the both ends of the box or the bottom of the box to lift it. So touching it means you are having a contact with that object. So contact force is the force that you exert on an object by touching it. Now let's go to non-contact force. Non-contact force, a force applied to an object by another body that is not in direct contact with it. Now, there is something called gravity. It's an example of non-contact force. Now, we can't see the force, but whenever you jump up, what happens? Do you stay afloat? Do you stay afloat in the air? You are suspended in the air. No, you come down. Whatever goes up must come down. It's a law of gravity. It means all that goes up comes down. Why? It's not an invisible force. It is not a spiritual force. It is not an invisible being that is pushing all things down to the earth, but the force of gravity. And that force, we can't see it, yet is acting on everything on the surface of the earth. When a mango ripens, or when a mangoes get ripe on a tree, it falls down. What pushes it down? When an apple gets ripe, it falls down. What pushes them down? Is the force of gravity. Unseen force, yet is pushing everything down. It is not in contact with the body, yet is pushing the body. That is what we mean by non-contact force. A force that pushes or exerts force on another body without coming in physical contact with it. Another one is your magnetic force. Now, a magnet is a piece that it has the ability to attract metals. Now, if you bring a magnet here and you put a magnetic material close to it, for example, a nail, the magnet does not have to come in contact with the nail before attracting it. Yes, because the magnet has this force or force field around it, which attracts everything metal to itself without coming in contact with the metal. That is non-contact force. You get it now? Another one is your electric force, what we call electricity. Now, we all don't know where electricity comes from, but yet it has the ability of powering every appliances in your house. And it has the ability to transfer from whatever medium into a human being. So all these that I've mentioned are non-contact force. Force that is exerted on an object or a body without having a physical contact with that object or body. Is that clear? All right, let's move on as I explain that in details so that you can get the clearer picture of contact and non-contact force. So let's take them one after the other. So let's go to contact force again. I said here, a contact force exists between two or more surfaces when the force or source of the force it is in contact with the object. I take that again. A contact force exists between two or more surfaces when the force or source of the force is in contact with the object is acting upon. Let me explain. Contact force. Contact means touching, just touching. The two objects must touch. I want to kick a ball, I must make sure my leg touches the ball to kick it. You get it now? I want to push a thing, I must make sure my hand touch the thing to push it. I want to lift an object, my hands must touch the object to lift it. That's contact force. And other examples, I said here, for example, when people are pushing a car, they place their hands on the car and push it. Other examples of contact force include pull and push. I've explained that earlier. Frictional force, which is the force that opposes motion between two surfaces. Then reaction forces, tension forces, and upthrust. I'm going to show you an upthrust force. Now, do this little experiment in your bathroom. Get a bowl, or what you call trough. Some of you call it bath. That thing is wrong. It's not a bath. There's nothing like bath. I don't know where you invented that from. It's a trough. T-R-O-U-G-H. Trough, or you call it a bowl, all right? It's a big one. Get a big one. Fill it up with water. Get a ball. Now, don't do it in your living room. I'm warning you. Else, you're going to splash water everywhere in your living room. Don't do it in your bedroom. You're going to get the whole place wet. make sure it's in your bathroom. So fill the bowl or trough with water. Now get a ball, a rubber ball. Make sure you press the ball down to the bottom of the bowl or down to the bottom of the trough. Now, when it gets there, immediately release your hands and see what happens. What happens is the ball is going to be tossed up with a great force. That means the force of the water will push the ball upward. That's what we call upthrust, upward push of an object with greater force. Then the ball will come flying up into the sky and the water will splash. So that is what we call upthrust. It's also a contact force. Let's go to the next one. Is a picture explanation of pull and push. I explained earlier that push is when you take an object away from you. It's the force that takes an object away from you, while pull is the force that brings an object closer to you. You can see here various pull and push. You can see this is push, this is push, this is push. You also push a button or you press a button. So this is pull. You're bringing the object closer to yourself. So look at the picture and identify the pull and push picture here and hit me up. And I said you have the option to send a feedback or your question directly to me via my Gmail. What that means is you can send a message directly to me in my Gmail and I will get it. The option is now included in your profile, your page. I hope that is clear. So identify this picture and tell me which one is pull and which one is push. Let's go to the next picture. Yeah, I explained that earlier, but I just needed to use this picture representation to further explain that. Push and pull. I said that a pull is a force that moves an object close. Can you see that? You can see that? That moves an object close. So when you pull a thing, you are moving the object closer to yourself. And you see the picture here? So you can see this is a towing band pulling this. Now, this here, a push, a force that moves an object away. You see? So that is push and pull. All right, now let's go to non-contact force. I said non-contact force is a force that acts on an object without coming in contact with that object. A force that acts on an object without coming in contact with that object. They don't touch. The two objects do not touch. Now let's look at it. Non-contact force. This is the force acting at a distance without a physical contact with the object it's acting on. It's acting from a distance. Example, gravitational force. I explained that earlier. Examples of non-contact force are gravitational force. And what is gravitational force? Gravitational force is the pull of the earth on all objects which make them fall to the center of the earth. All right? Which makes all objects fall to the center of the earth. That is why everything that goes up must come down, provided is within the earth. All right? So, but the higher you go into the sky, the lesser the gravitational force. In some outer planets, it is zero gravity. That is why people who travel to space float, because there is no gravity, there is no force that would push them down to make them walk on the ground. So that is why in space, people who travel to space float. You get it now? So another example, like I said, is magnetic force. I've explained that. That is the force that enables a magnet to attract metal to itself without touching the metal. There's another experiment I want you to carry out. Get a flat table in your house. Put a magnet underneath the table and put a metal on top of the table. Magnet underneath the table. Make sure it's touching the end of the table at the bottom, all right? and a metal, probably a nail, on top of the table. Now, what you will realize is that the nail will be stuck at that position, despite the fact that the magnet is not physically touching the nail. Now, if you move the magnet underneath the table, the nail also moves in the direction at which you are moving the magnet. As you move the magnet, the nail moves. As you move the magnet, the nail moves. So that is a non-contact force. Force that is exerted on an object or applied on an object without the object coming in contact with the other objects. So, and the last one is electric force. All right, let's go further. Here, I explained that everything that goes up must come down. Here in the picture, you're seeing a mango tree or an apple tree, and you see that some apples are falling to the ground. What brought them down? It is not a bird, not squirrel, not human being. You find out that if you have a tree of orange in your house or apple tree, and if you went to bed the night before and you came out in the morning, you see a lot of the fruits on the floor. What happened? They got ripened and force pushed them down and they fell down. So that is non-contact force, gravity. So a non-contact force is any force applied to an object by another body without any contact. The body does not have contact with it. An example is this apple tree. These apples on the floor has been brought down by gravity, a force that pushed everything downwards. So I also put here magnetic, they also put here magnetic force, gravitational force, electrostatic force. Let me explain what electrostatic force is. Yes, I needed to also perform a little experiment. Get yourself a comb. Yes, the comb that you use to comb your hair. Let me get my own comb. Okay, here is my comb. Now do this. You need to rub the comb on your hair vigorously. Make sure you rub it very hard on your hair, very continuously for like 2 minutes. When you're done, get a piece of paper or a strand of your hair. If it's a strand of hair, place it on your paper and try to use your comb to touch the air. Before touching the air, what you realize is that the air is just going to fly up and cling to your comb. It's going to get stuck to your comb. What has happened? The comb that you rub vigorously on your hair has been charged up. Yes, has been charged up. And trying to use it to touch the strand of your hair, you are applying the charges on the comb will be exerted on the strand of hair, thereby attracting it and it will get stuck to the comb. That's what we call electrostatic force. You can also use your pen. Rub your pen on your hair, rub it very hard on your hair for like a minute or two and tear a piece of paper and try to move your pen closer to that paper. What you see is that the paper is going to get stuck to the pen. So one body that is electrostatically charged will also charge another body by applying force to that body, and therefore the other body that is now charged would get stuck to the body already charged. That is what we call electrostatic force. Now let's continue here. Let's go to effect of force. What are the effects of force? Now, I told you from the initial definition that when you apply a force to an object, it will make the object to move. Now, the things that happen when we apply force to a thing is what we're talking about here. Effect of force. What happens when a force is applied to a thing? What happens when a force is applied to kicking a ball? Now, listen to the effect of a force. The following are the effects of force on an object. 1, force causes an object to move from a state of rest. Now, let me further break that down. Force causes an object to move from the state of rest. If you place a ball at a particular position the ball remains there. It doesn't move until human being, someone goes to kick the ball. Once the person kicked the ball, the person has applied the force, therefore the ball moves. Now, it might not even be human being. It might be wind. The ball is kept at a particular place. The ball will continue to remain there until maybe there is wind that blows the ball from where it was to a new place. That is the effect of force. So force causes an object to move from its state of rest to another place. Number two, force changes direction of an object. I have done it before. I think I've taught this force in the class before lockdown. Now, if you get a ball, someone's staying ahead of you and you are staying where you are. If you begin to kick the ball to yourself, it's going to be going in an horizontal motion or vertical motion or to and fro, upward and backward motion. You are kicking the ball in that direction. But if someone now comes in between you guys, as one person kicks, he now kicks the ball in an opposite direction. The ball is not going to go in an upward and backward direction again. He's going to go in the opposite direction that he has kicked the ball. Now, what that means is that if something is flying in this direction, someone now comes this way and kick it. He's not going to go in this direction again. He's going to go in the direction of the force. I hope you get it now. Something that was coming like this, in this direction, and someone comes to push it this way. He's not going to go, he's not going to continue in this direction, but in the new direction that it has been kicked or pushed or pulled. So force changes the direction of an object. Number three, force sets an object in motion. That is, force causes the object to start moving. Yes, an object that was formerly laying or staying still. But when someone goes there to kick it, the ball or the thing will start moving. Okay? A paper that was lying gently on the table will not fly until you turn on your fan, and the wind that blows around the house can blow the paper from where it was to a new direction. So force causes an object, sets an object in motion. Motion means movement. When something is in motion, that thing is moving. And the thing will continue to move until an equal opposite force is applied to that thing. So the thing can either change direction or stop moving. I hope that is clear. All right, let's go to number four. Force stops an object from moving. I just said that. Force stops an object from moving. An object that is going in a particular direction, if an equal opposite force is applied to that object, the object will stop moving. If you kick a ball in this direction, if an equal opposite force coming ahead of the object hits the object stops moving. That's what that means. So force stops an object from moving. And lastly, force causes an object to either accelerate. To accelerate means to continue moving. Now, in your dad's car or in your mom's car, there is something called gear, and we also have accelerator. Now, if you're driving a car, the more you apply the accelerator, the faster the speed of the car. Do you get it now? So if you press hard on the accelerator, the car speeds faster. You get it now? So when an object is accelerating, that means that object is moving. And the more the acceleration, the more the speed of the object. Okay? The higher the number of, okay, let me give you an example. The fan in your house has this oscillation. What we call oscillation is the button that regulates the speed. Some of you, the highest speed of your fan is 1. If you move it to 2, it's speed faster. 3, faster. 4, faster. So the more the number, as the number increases, the speed of the the speed of the fan or the oscillation of the fan moves faster. While some, the number 1 is the highest speed. While some fan, number 5 is the highest speed. So as you tune, the speed of the fan increases. The same thing with acceleration. Acceleration means something that is moving, something in motion, continuous moving continuously. So force causes an object to either accelerate, that means continue moving, or decelerate, that means to reduce the speed of that object. So if you're releasing your leg from the accelerator of a car, the speed of that car will also reduce. If you reduce the number of your fan, the speed of the fan will also reduce. It's as simple as that. So these are the 5 effects of force. All right, let's go. The rest things I want to show you here are just picture representation of all that I've said about force, and we will come to the end of today's topic. Look at this picture. I quickly need to state this here. Now, who discovered force of gravity? There is a man, a scientist, a renowned scientist who is now late, called Isaac Newton. Isaac Newton sat on a mango tree, and on an apple tree, and an apple fell on his head while he was deep in thought, studying. Then, there and then, he thought and reasoned, what could have brought this mango? What could have made this mango to fall on my head? It must have been a force. A force obviously must have pushed the mango, and the mango or the apple fell. But I can't see the force. Oh, it must have been gravitational force. Yes, the pull of the earth on all objects that makes it fall to the center of the earth. Yes, and there it discovered gravitational force or force of gravity. And that ever since then, the measurement of gravity has been named after Isaac Newton. That is why force is measured in Newton. That Newton is a name of the scientist who discovered gravity, Isaac Newton. So Isaac Newton is the father or a great inventor, a scientist in his days. So let me mention here the first law of motion. The first law of motion states that an object, a ball, like you can see, a ball at rest, that ball is not moving. Is at rest, is not moving. To be at rest means is not moving until this girl here goes there to kick it, and this boy here goes there to kick it. So an object in motion or at rest tends to stay there as long as nobody goes to kick it, or nobody goes to push it, or nobody goes to poke it. But the moment someone goes there to push or exert a force on that ball, on that object, the thing will continue to move. Do you get it now? So an object in motion or at rest tends to stay that way unless acted on by an outside force. That's what that means. Let's go to the next picture explanation, which is the pull or push. I said earlier that a force is a pull or push effect acting on an object, which makes the object to move from where it was to a new place, or also can stop the object from moving. Now, I also said that we have 2 types of force, which is contact force, a force that is applied on an object by coming in contact with that object. So a contact force, a force that can cause or change motion of an object by touching it. Motors and gears operate through contact force. Contact, for example, friction, normal force, air resistance, applied force. Non-contact force, force that results when 2 objects are not in physical contact with each other, yet are able to exert a push or a pull. Non-contact force examples: gravitational force, electrical force, magnetic force. So next picture explanation here are just showing examples of contact and non-contact force, which was explained in the earlier slide. Interaction between objects that touch, that is contact forces. Applied force, you can see. Now, the same thing, you know, baseball. In baseball, you use a baton or a bat, and that ball is metallic sort of. Someone will be at one end, the person will throw the ball, and you at the other end, you try to apply equal opposite force by hitting your bat on that ball to kick it to a particular direction. So that is applied force. This is spring force, is a contact force. The force that is applied to a spring that makes it to bounce, spring force. And we also have drag force. If you're using a parachute, you need to pull the string of the parachute to make sure it helps the gravity and the force of gravity acting on the parachute to help bring it down safely to the ground. So that is drag force. And this one is frictional force, the force that opposes motion between two surfaces. And we have normal force. And for non-contact force, is attract or repel even from a distance. The force that attract a thing or repel a thing, especially magnets. Magnet can either attract a metal or repel a metal. Attraction means to bring it close to itself. Repulsion means to push it away. Now, when does a magnet repel a thing? There is a law of magnet that says opposites pole attract while same pole repel. What that means is that north and south of a magnet attract, but north and north of a magnet repel. They push themselves away. South and south of a magnet repel. They push themselves away. But north and south attract. That means there's force of attraction. Then we also have electric force. I've explained that earlier. Gravitational force. You can see this man sitting under an apple tree, and the apples are falling off and hitting his head. That's gravitational force. All right, on to the next picture here. You can see other explanation of contact and non-contact force. Force experienced by bodies when they are in physical contact with each other, that's contact force. Example is muscular force. When you are pushing, you can see these guys, they are pushing this box. And in order to get the box pushed, they need to use muscular force. That means the strength, their energy. They need to use that to push the box. That is muscular force. And here is frictional force. The force that is acting in opposite direction to that box that is being pushed. Force that opposes motion. Now, force due to the action of muscles. That's the one above. This one is force acting opposite to the direction of motion. I just said that earlier. So let's go to non-contact force. Forces experienced by bodies even if they are not in physical contact with each other. First one is magnetic. Force exerted by a magnet. I said that earlier. You can see these nails. These nails attracted to the magnet. And this electrostatic force I explained by taking your comb, rub it vigorously on your hair, and try to use it to and place it close to the strand of your hair or a paper. Force exerted by charged body on another charged body. I told that earlier. And lastly, gravitational force. Attractive force exerting between two objects. The force of the earth pulling everything downwards to the earth. You can see here again types of force. Non-contact forces, gravitational, electromagnetic. Electromagnetic means both magnets and electricity. So electromagnetic means electric and magnets. And you also have nuclear. Contact forces, you have pushes. Pushes is friction and normal force. While the last one is pulls. And you have example of that is tension. All right. Let's see the next picture explanation. All right, here, forces and vector. I said force is a vector quantity because it has magnitude, that is weight, and goes in a particular direction. Obviously, if you're pushing a thing, you must be pushing it to a particular place, in a particular direction that leads to the place where you are pushing that thing to. Two teams that are playing football, one team from here will be playing the ball towards the other direction of the other team. So go and kick the ball into the net of the opposite team. Likewise, the team here are also kicking the ball towards this direction to go and kick the ball into the net of their opponent. So that is to tell you that the force that is being applied is going in a particular direction you want it to go. Pushing a box, you are pushing it to a particular direction. So the box has weight, which is called magnitude, and it is going in a particular direction. So that's what makes force a vector quantity, because there is magnitude, weight, and direction. So that's what makes force a vector quantity. You can see here contact force. This is contact force, friction. This is non-contact force. When you rub a balloon, the balloon can also do that trick, electrostatic force. When you rub a balloon on your hair, what you feel is if you now use that balloon to touch another thing, like your strand of hair, is going to be attracted to that balloon. This is upthrust, yes. This is the experiment I told you to try at home. Try to get a trough or a bath, fill it up with water, try to push a ball to the bottom of that trough. What you see is that the ball will shoot up with great speed. It's called upthrust force. And the last one is non-contact force, which is force of magnetism. All right, we have come to the end of today's class. I hope you understand everything I have explained. And that is why I took you through this picture explanation for better understanding of this topic. I said force is a pull or push on an object which makes the object to start moving or stop the object from moving. And I said there are two types of force. One is contact force, that is the force that is exerted or applied on an object by coming in contact with that object. Example is push and pull. You have to touch that thing before you are able to push it. You have to touch that thing before you are able to pull it. Another example is friction. Another example of friction is when you rub your two palms together vigorously, is going to generate heat. But if your hands are very dry, you find it very difficult to rub your hands together easily. It's not going to glide smoothly. In order for you to move that hand smoothly and easily, something needs to be done. So when your hands are dry, is a force that is not making it to glide smoothly over each other. And that force is called friction. The force that opposes motion between two bodies or two surfaces. You can see the upper part of my arm is one surface. This lower part of my arm is another surface. And I'm putting them together. That means they're coming in contact by rubbing, right? So if they don't move smoothly or easily together, that means friction is being experienced. But in order for me to move my hands smoothly and easily together, I need to apply lubricant. That is what? Oil or grease. So when I apply that, they will be able to glide smoothly and easily over each other. Okay? And that is contact force. Example of contact force: pull, push, friction, and upthrust. I also said another example of force is non-contact force, which is the force that is experienced when an object does not need to come in contact with the object he is applying force on. For instance, everything that goes up must come down. Throw a pen up, it falls down. There is a force that pushes that push that pen downwards, or that pushes that pen downward, and that force is gravitational force. You are not seeing the force. We can't see that there is a hand or hands that are pushing those objects downward, yet they fall down. That is gravitational force. Example of non-contact force are gravitational force, magnetic force, electric force or electrostatic force, or electromagnetic force. So that brings us to the end of this class. Make sure you play this video as many times as possible to understand all that has been said in this video. And yet, if you don't understand a thing, feel free to send a mail to my Gmail on the option on your page, and make sure you access the lesson note online and do all your assignment. Make sure you are obeying all the safety precautions as given by WHO and NCDC, which are always washing your hands under running water with soap at interval and applying hand-based sanitizer. And if you must go out at all with daddy and mommy, make sure you are all wearing a protective nose mask. I pray we shall not contract this deadly coronavirus and we shall all be safe. And at the end, when shall be over, none of your family member shall be missing. All right, stay safe. I love you. Until I come your way again, I remain your humble and caring teacher, Mr. Ogunlaro. See you and bye for now.